Hi sir, my name is Bittu Kumar and today we are going to perform lab 4. Lab 4 task is to understand diode characteristics and half-wave rectification. Our objectives of this experiment is to understand the current voltage characteristics of various types of diode through practical experiment. Today we will need a diode, 1 kilo ohm resistor, 10 kilo ohm resistor, capacitor, analog ADALM 1000 kit and multimeter. First part of the experiment is to check diode current voltage characteristics. For that we need to make this circuit. We will follow this circuit diagram in which we have a voltage supply which we will give from ADALM kit and one diode and 1 kilo ohm resistor. This circuit is in forward bias to pass the current, but if we reverse this diode then there will be no flow of current through this resistor or through this circuit. We will check that only practically. So let's go to our circuit. We will make our circuit in series. We can see that the cathode white part of diode is cathode, that is negative, and black part is anode, that is positive. Positive is connected to channel A and negative is connected to ground. We will power this and check the reading in multimeter. What is the reading? For that we will connect our multimeter. So we'll check the reading across the resistor. So I have connected it. Let's power it up. ADALM kit has been powered up. Now let's go to Pixel Pulse software and check the input voltage and flow of current. First of all, we will give 0 volt to the circuit and check what is the flow of current. We have given 0 volt and check the reading that it is almost 0 ampere flowing through the circuit. Now we will change the 0.0 volt to 0.4 volts and check is there any flow of current now. Then now also we can see that there is no flow of current through the circuit. Now we will change it to 0.8. We can still see that there is no or slight change in the flow of current through the circuit. Let's increase little more volts, 0.9 volts, and check it. Now we can see that the flow of current in the circuit has increased to 0.03 milliamperes. Let's change it to 1 volt and we can see that it has changed. We should change once more to 1.5 volt and check. I have increased the volt to 1.5 volt and now we can see that there is change in flow of current through the circuit which is readable or recognizable. Now changing to 2 volts, we can see that the current is increasing rapidly. In first of all, from 0.4 volt to 0.8 volt there was no change in the circuit because this diode has a variable voltage of 0.5 to 0.8 volt, so there was no flow of current through it during that input voltage, and when we increase the voltage from its variable voltage it started to flow current through it. Now our second part of the same question was to reverse the diode and check the flow of current. For that we will just reverse the diode and this will come in reverse bias mode. I have reversed the diode and now we will check the input voltage, flow of current. For 1 volt we will start from 1 volt. We can see that there is 0 amperes flowing through it. We will change it to 2 volt and still there is no change in the flow of current through the circuit when we have reversed the diode, that is reversed biased condition. So this is you can see here IV characteristics of a diode. Now our second question was to construct a half-wave rectifier circuit. For that we will use this circuit in which we have to replace 1 kilo ohm resistor to 10 kilo ohm resistor and add a DC source with a AC source. from our add alarm kit. So now let's go to our circuit. This is our circuit, that is same like first one, just we have replaced this resistor that was 1 kilo ohm earlier, now it is 10 kilo ohm, and we have this wire that is connected to channel A and this wire to channel B, which is giving a voltage of 2.1 volt DC, and this is our output node, channel B node, and I have connected my multimeter and we will check it on pixel pulse now. That if we will check that our half wave rectifier is constructed or not. Yes, you can see that my half wave rectifier is completed successfully, and this is half wave rectifier means that it will show only positive cycles of the sine wave which we are giving as an input, and as we increase our input voltage from 0 to 5, we can see the difference in half wave rectified output. This is 0 now we'll change it to 1 voltage and we can see change in half wave rectified, and we can see change in voltage across the nodes also. We will change it to 2 volts now. See, we can see the change, and here also we can see the change. So this is the second part of half wave rectification. In the same question, we have another part that we have to introduce a capacitor in series with the resistor to rectify that wave, and we will see now output of this also. We can say that the wave has been rectified more, and this is the output after the addition of capacitor between them. Now our next task is part 3, and in which we have to repeat part 2 but with an LED. We have to replace diode with an LED. So let's get back to our circuit after replacing LED. See, I have replaced the diode with LED, and now we have to go to Pixel Pulse software and check the half wave rectification of this LED. So we have come to Pixel Pulse. Here I have set the maximum peak voltage to 4 volt and input voltage to 0.5 volt, and we can see that our LED is not blinking. We will increase the input voltage to 1 volt and check. It's not blinking, and the voltage between the nodes is also so negligible, 0.02 volts. Now we will increase the maximum peak voltage to 5 volt and check what happens. Now we can see that it has rectified the wave. Negative sinusoidal wave has been rectified and only positive cycles wave are here, and we can see a change in our circuit also, that LED has started blinking and there is increase in voltage between them too. And this is at 50 Hz frequency. We will change this also. First we will increase the input voltage and check. If we put to 3 voltage, what happens? And see it after changing the bulb has started blinking much more faster than earlier. So this happens after the changing the hertz. What if we change to 4 volts? The bulb is glowing slightly. So this was our third part of lab 4. Our fourth task is to repeat part 1 with a Zener diode with using 200 ohm instead of 1 kilo ohm resistor. So our final circuit will be same as part 1. We have to just use a Zener diode instead of a diode, and 200 ohm resistor instead of 1 kilo ohm resistor. I didn't had 220 ohm resistor, so I have used 1 kilo ohm resistor in parallel. It will give the same output as 200 ohm resistor. So now let's get back to Pixel Pulse software and see what happens. Here if we are giving input voltage of 0, then the current flowing through this Zener diode is also 0 ampere. When we increase this slightly to 0.5 volts, we can see there no change, but if we change it to 1 volt, we can see there a slight change, 0.02, and when we increase it to 1.5, we can see change there also. 0.07, 0.07. As we were getting changes in diode, we are getting the difference between diode and Zener diode is that diode allows current to flow through forward bias, but Zener diode allows it in reverse bias also. The current flows both sides, but there is a slight change that Zener diode acts as a voltage regulator. It means it has fixed voltage across its nodes. So this is the IV characteristics of Zener diode.